Okay, let me explain about the introduction. Okay, let me bring to you two keywords that I use today, which is the internal combustion engine, and the one more is the ceramics. Okay, what is the internal combustion engine? Okay, internal combustion engine is the heat engine where the combustion of the fuel occurs in with an oxidizer in the combustion chamber. Okay, and then the IC engine have achieved a very high level of technical development and characterized with high power density, high torque, and reduced exhaust emission. Okay, next, what is the ceramics? Okay, the ceramics is an inorganic non-metallic solid made up of either metal and non-metal compound that have been shaped and then hardened by heating to the high temperature. In general, they are hard, corrosion resistant, and brittle. Okay, and the ceramics that we are talking about in this topic is the advanced ceramic, which is a new material. The advanced ceramic are not generally the clay, instead of either based on oxide or non-oxide. Okay.
Lower fuel consumption is the advantage of using ceramic in engine combustion. It is not only increase the performance but also can reduce the pollution. I will explain about the material properties of ceramic used in engine combustion. The first one is alumina. Alumina is widely used ceramic, especially in electrical parts, as it acts as an insulator. It is not considered as the suitable material because it has low fracture toughness and high thermal conductivity. Alumina is most durable refractory material to mechanical loads and ceramic, and because it has melting temperature about 2000 degrees Celsius, and this low melting temperature has limits its applications. The second one is zirconia. Zirconia has a very high fracture toughness and highest maximum temperature among all of the ceramics. It has 2700 degrees Celsius melting temperature and can retain some of their mechanical strength as it close to its melting point. But it has low creep resistance and low thermal shock resistance. Zirconia also has been used in heat engine as it has high temperature capability and low thermal conductivity. The next one is silicon nitride. Silicon nitride has good thermal shock resistance and good creep resistance, but it is poor in mechanical strength as has low fracture toughness. It also cannot be heated over 1900 degrees Celsius because it will dissociate into silicon and nitrogen. However, silicon nitride has received the most attention for use in internal combustion engine among various engineering ceramic. Lastly is silicon carbide. Silicon carbide known as the material that has a very high hardness. It has a lower fracture toughness than the silicon nitride, and this has made silicon carbide remains problem. But silicon carbide still used in any application that not need mechanical strength and integrity.
Now I'm going to tell you about the effect of ceramic engine to our environment. Ceramic engine can be very useful for our transportation industry. However, people nowadays use car as their main transportation. If they want to use ceramic engine for perfect combustion, they have to notice the effect of ceramic engine to our environment. There was 3 categories effect to our environment. First is global warming potential, number 2 is human toxicity, and number 3 is pollution. Global warming potential. Global warming potential is known as GWP, which means relative measure on how much heat traps in our atmosphere, while global warming is known as climate changes in Earth's temperature that rises over centuries. GWP depends on these 3 factors. First is absorption of infrared radiation, number 2 is spectral location of its absorption wavelength, and number 3 is atmosphere lifetime. The higher the heat, the higher the infrared radiation emits, with more infrared radiation lead to global warming. However, ceramic engine increase combustion efficiency, which means increased performance, reduced fuel consumption, and thus less pollution. Human toxicity. Human toxicity is a decay where substances that can damage organisms in a human body. There were toxicity that came from ceramic to human. There were dust hazard, radioactive uranium oxide, allergies, and dry skin. Those showed how much dangerous of using ceramic in a part of human life. When ceramic engine is used, there was probability that it will produce harmful substances to environment. Pollution. Ceramic engine was invented because investors want to make an engine that have high combustion rate. Ceramic is a high temperature material, which means it produces higher temperature for engine combustion. With higher combustion of fuel can increase combustion efficiency, thus that can lead to increase in engine performance, reduced fuel consumption, and less pollution to environment. Big companies such as Isuzu Motors and Toyota was one of the first companies that used a ceramic engine. People nowadays also aware about the pollution and take action to buy environmental friendly car to reduce pollution and save the earth.
Okay, for a suitable engine material, it should have twin capabilities, which is be able to operate at high temperature and contain heat generated within the combustion chamber. Okay, for advanced ceramic, use is zirconia. Zirconia is considered as most suitable ceramic that used in engine combustion. Okay, Ford Motor Company has successfully used in engineering ceramic. Okay, zirconia has relatively good mechanical strength where it is high fracture toughness and high bend stress. Okay, it has twin relative properties which are high temperature capability, and next is low thermal conductivity. For example, if fuels contain chemically active and corrosive substances, resistance against hydrothermal degradation and resistance against oxidation are highly desirable attributes of a ceramic for an internal combustion engine. This is because zirconia ceramic is unlikely to be oxidized.
There may be other existing work on the use of ceramic for automotive application. It can be clearly seen that what has been reported in this review was ceramic application in the major automotive engine component, for whose optimization have tremendous influence on the improvement of the engine thermal efficiency and output power. The advantage of ceramic inherent properties such as their resistance to both oxidation, hot corrosion, and wear, as well as their high thermal insulation, has no doubt give it an hand over metal and their alloys as high temperature material candidate for automotive application.